Hello and welcome to Programming 2 Tutorial 4, Introduction to Console Logging. In this tutorial, we will be setting up and using console logging. Console logging is a tool that is available within Unity that allows you to print error or warning messages within your own code rather than just allowing Unity's own code to do that for you. You can use these logs to debug issues within your code and find problems with different values that may be problematic within your code. By the end of this tutorial, you should understand how to effectively debug your code, as well as why we use logging in order to create easier to read errors. And lastly, you should know how to use logging in order to help your own debugging habits. If you are looking for the submission for this week, that will be covered in the recap section. Until then, let's get started. All right, so the very first thing that we want to do is actually just open up our project. And as we can see, we can just open this up and we'll pause until it's done. All right. So today's tutorial is all about debugging, but not just debugging. So today's tutorial, you'll be about, hopefully close to, this will be about halfway through the semester, close to about 5, coming up on reading week. And so this is a grand place to show debug logging. And so debug logging isn't just what we did last week, where we added in those checks to our player controller. I'll just wait for it to open. And where we basically added in these using controller input, using mouse input. And we can easily just go, we look down at the console. Unity's being a little slow sometimes. So if we look at the console, obviously we're using mouse input right now, but if I pick up my controller, using mouse, controller, and so on. So this is a log, but this isn't the only thing that we can do with Unity's debug system. And this by far is not the most useful tool at our disposal. Granted, it is a very useful tool as it allowed us to see whether or not we were using controller or mouse input. However, by far the best tool that is really not usually talked about and not something that I was taught about when I went through this program. And that is Debug Log and Log Warning. So let's say, for example, so let's imagine, and here, so I opened up trusty old paint.net. So let's imagine, so this is our controller. Ignore how poorly it is drawn. I'm a programmer, not an artist. And that's our right stick, and that's our left stick. And then this is our mouse. And so this mouse, it points to a point on the screen. And we already talked about this back when we wrote the, sorry, it's up here. When we wrote the aim player function. So with mouse input, you get a screen point. So let's say the player is right here on the screen. We're gonna color the player red. And then let's say the mouse is up here. Well, it's not as simple. So theoretically, what you can do is you have two choices. You can, number one, convert the mouse into a screen position. And obviously that takes resources. Or you can convert the player, or sorry, you can convert the mouse into a world position, or you can convert the player into a screen position. So screen position, start at 0, 0, and go to your resolution. That says res, for anyone who's wondering. So if we were to get a screen point, we can simply get a vector from here to here. So we will have the position of this from 0, 0 to resolution. And we'll have the position of this from 0, 0 to resolution, which allows us to, if we just subtract them, get the direction that the mouse is from the player. And then we just rotate the player towards that. It's much simpler on controller, where the controller is just, the controller starts at, like its default position is 0. And then if you move it up, it goes to 0, 1. This way is 1, 0. This way is 0, -1. And this way is -1, 0. And this is an XY system. So as you can see, I mean, as you can clearly see from this, the sheer amount of math that we have to do is much simpler. But what else? What did we learn in math? We learned about normalized vectors. And so this is a normalized vector. And that's perfect. That's exactly what we want. This is not. So granted, this particular issue in this particular case won't cause problems. But there are cases in which it will. For example, if you were using the raw input values and you were using mouse to move your character instead of aim your character, you could be moving your character at a significantly faster rate just based on how far your mouse moves, rather than having it be a constant rate no matter how far your mouse is away from the character. So in this case, we want to make sure that this is a normalized value. And ignore the fact that I didn't write the entire word. It wouldn't be legible if I did. But we want this to be a normalized value, just like this, because we want our values to come in the same. We want them to be as expected. And so if we have them both coming in as normalized values, then that's perfect. So what can we do? Well, why don't we check if it's a normalized value? So we have this wonderful, wonderful function called Debug Warning. And so you can make this a warning. So Debug Log Warning. And we're going to say, look at direction not normalized. And so we're going to check if it's normalized. And pretty simple check. You can pretty easily just check, or rather, we don't even have to check look at direction. No, we should check look at direction, actually. I was going to say we could just check aim position. However, we are actually calculating a new vector here, and we want it to be normalized. So we can, if look at direction, is dot normalize equals. So if the normalized version equals if the normalized version is equal to the regular version, and it's worth mentioning there is a difference between normalize with a capital is a function, and that actually converts the active value. Normalized returns a separate value and doesn't change the value of look at direction. So the value of look at direction stays the same, but all we're doing is, if you read this, returns this vector with a magnitude of 1. So we want it to be is not equal. So look at direction is not normalized. So let's run. And we should see down here, look at direction not normalized. That's a problem. So what do? Well, we could just do dot normalize. And then from there, we make sure that we saved and we run. And as you can see, there's no issues with mouse input now. We don't print any more warnings. Now, if I switch over to controller, somehow in the passage of the value, it's getting unnormalized. And that's okay. So the way to fix that is, so you can actually, and this is a good place to show this functionality, you can actually process your values. So if you click on right stick gamepad and process, normalize vector, save asset. Now if we run again, no warning. And so in this specific case, obviously normalizing was something that we knew we wanted to do. But if, for example, we add a new controller and we forget to normalize the value, now that warning will be there and will tell us, hey, this value needs to be normalized. And while that isn't obviously like, it isn't a deadly error, in the end, it can be. There are a lot of very small things that will seem very, very insignificant as a user that end up being very significant as a player. Another thing that we can do is simply just go around, and I need to stress this. This is something that needs to be stressed. When you add these debug logs, they are not just there for you. So let's say another member of your team starts using your code, another programmer, and they don't know that you want to make sure that look at direction is always normalized, no matter what they add. They don't know this. Well, because you have this warning logged here, when they go in and try to use an unnormalized value, it's going to tell them. So if I, remove the processor, save, so let's say I'm a new developer, I just got added to the project, and I'm like, oh, okay, things seem simple. I'll just add a new controller. Oh, why am I getting all these warnings? The whole point of these, and they won't seem useful to you. That's the point. It's your code. These debugs are not there for you. They are there for your teammates, for other users. They're there so that For example, someone new can come join your team and you don't have to sit there and explain them every single quirk of your program. You don't have to sit there and explain everything bit by bit. And that's the whole point of it. Um, and so you can add debug logs anywhere. Now, the reason why we made this a log warning is because normalizing in this specific case, it's not a deathly, like, it's not going to break the program. In this specific case, there are cases where it will break the program. And in that case, what you want to do is log error. And so log error does pretty much what you think it does. It just logs an error. It shows to another programmer or to another user that there is something deathly wrong. That they need to fix it ASAP. And for me, I just want this to be log warning. For example, another thing that you would like is, let's say, like, these are just things to make sure of. So yeah, this. So you see this if RigidBody equals null. So in this specific case, if it is null, you know, like, you're not always going to be able to get component. And I'll tell you that grabbing the component isn't that bad. But there are cases where the component won't be accessible on this object. For example, player controller is attached to our player. But what if it was a class that we created for handling physics? Now that would need access to the enemy rigid bodies and things like that. So you wouldn't want that to ever be null. So in this case, you can do, debug.log warning, and then rigid uh, rigid body is null. Uh, please set in inspector. Now, because this isn't a deathly error, because we have this line here, we shouldn't be grabbing this every time at runtime when there's such a simple solution. So if you go down here, rigid body, you should drag and drop rigid body. So if we run, rigid body exists. But if I were to click on this and click delete, and we run, rigid body is null. Please set an inspector. The game still functions, but we've added this warning because it shouldn't be done in the code when we can easily set it up here. It's just an optimization thing, which, granted, you don't need to worry about as much as you will in later years, but it is something to think about now. It is something to consider, just as a concept. And so, every time we run it now, we're going to get this rigid body is null. Please set an inspector. Game still functions just fine. Everything still functions just fine. But we should set it. And this warning is going to stick around until after we finish, until we clear it. And that's a good thing because that can remind us, hey, oh, we should put the player rigid body in the inspector. And that's it. Warning's gone. As for other ways that you can use it, for example, in They're just like different places that you can add them to the code. And granted, your task for this week, which will be talked about in the recap section, is quite literally just going to be finding places to put it, finding good places to put it, and getting feedback on, or not getting feedback, and just like thinking critically about, would this help another programmer? Would this be important to remind them if they, make a new player and they forget to add their RigidBody because, the code will do it for me. Um, a lot of those, if, variable equals or is null checks are places where you can use that. Um, for example, hmm, you know, it's just a lot of different like things that you can do, things that you can check. Just go through the code, find those different places where it might be deadly, where it might be bad that X happens or bad that Y happens. For example, this, like, else, this is definitely, this is log error. This is a deathly thing. If our character can't fight, um, fireball cannon is uh, cacao demon weapon fireball cannon is null, and it's as simple as that. And that's an error. And if you'll notice, we actually don't set it in here. We just check if it's not equal to null. And so this is a great place to, if we were to go into our prefab, and for example, if someone were to, I don't know, modify Cacao Demon somehow, and accidentally delete Cacao Demon gun. That's it. Like, if someone were to accidentally delete that, so there's no gun attached to the to the Cacao Demon. If you were to run now, it's going to try and fire at you, and it's going to continue to give you errors. The Cacao Demon will follow you. It'll chase you, but it won't be able to do anything. And this error will stay there. And so this is an error that, for example, is good, because then we can just click on this, check out, oh, hey, this value is null. Go back over here, go to our prefab, double click it, be like, oh, the gun is null. That's weird. Fix it. Now if we run again, and there we go. And that's it. Those are a few different ways to use errors and warnings. The last thing that we can do is, for example, if we would like to, just simply mess around with different values and see what feels good, or we want to see to make sure what, for example, and this is the best usage that I've used this for. If we were to go into our bullet and actually, check here, we can write debug.log, so bullet hit enemy for, and then damage value, damage. And then we can just copy, paste, bullet hit player for a damage value. And then got to make sure to do it before the destroy game object. Bullet hit environment, because that's the only other thing to collide with. So now we have a few different, and this is just on our gun. And keep in mind, our gun is used for all of our weapons, except for the chainsaw. Chainsaw's the only one that this won't do anything to. So if you see down here, bullet hit player, bullet hit environment, and then one thing that I just realized is we are doing this one no matter what. And so we don't actually need it, funnily enough. But the point still stands. That bullet hit enemy for 3 damage. This is our shotguns. And we can go one step further. We can actually collision.gameObject.name. Sorry. Hit. So blank hit blank for blank damage. So here we want to put collision.gameObject.name, and then we put gameObject.name. So this game object hit the collision game object for damage value damage. And then so we can literally just this is a better way of doing it because we can just control X, put it there. So instead of logging in each of our if statements, we can actually just log what our bullet hits. And this obviously you can go in and we'll do this in a second because this is good for. But as you can see, shotgun pellet hit clone, fireball hit right wall, and then hit player, hit bottom wall, hit zombie, hit cacao demon, and so on. And you can see, like, let's say you have an issue in your game where your bullets are hitting an enemy but not doing any damage. Well, this is a great way to see whether or not your bullets are actually hitting the enemy. And as for the annoyance of it all, you can just go in and, for example, just just set up if, and this can be like, how we have this utility. So utility, we can just have static bool debug, and it's going to be equal to true by default. And so we could just go into here if utility dot, oh, forgot to make it public. Public static bool. Utility dot debug. And then you can just go in and enable and disable that whenever you want. So right now it's enabled. See it, obviously, as you can see. Things like this. But as you can see it here. And if we just go in here, make it false. And there is also another way of doing this. You can just create a script that goes on like an empty object. Just, debug enabler. Call this debug enabler. And we're just going to edit the script. And it's just going to be public bool enable debug. And then updates just gonna, and keep in mind, Unity does actually have a define for Unity editor mode and things like that. But this is one that you will have more control over. As in like Unity, the debug macros basically, and you can research those on your own. I'm only mentioning them just in case anyone knows about them. But so an update, you can just do utility dot debug is equal to enable debug. Be true by default. So if you go to utility, you just set it. Honestly, you don't even have to set it. Go to utility. So we have our debug enabler now. So if we go back to our game, we'll notice that we now have a button here. So, it'll see it, but we just disabled it, and now we're getting hit, and we're shooting our guns. And then we go into enable it again. This way you have full control. And feel free to write that script on your own. But yeah, that is the end of today's overview of the debug log error, and debug log warning values. And I fully hope to hear these being used, as they are extremely useful for debugging if you're ever lost. If, for example, you get lost in a tutorial and you're wondering why something isn't working, in some cases it may, like, you could easily write a debug log and that code isn't even running. I know for a fact that in previous years I have been helped in my classes and have helped people when I was a TA, and their issue was simply solved because they didn't run the function. And there's no shame in that. Everybody's done it. Everybody does it. Everybody will do it. It even happens to people who are like, well experienced. It doesn't matter how new you are. It doesn't matter how old you are. It is just a universal thing we sometimes just forget. But hopefully this helps with all that. Congratulations on getting through your 4th tutorial. Hopefully this one was a nice rest, a nice break from everything. Next week we'll be covering physics interactions, physics triggers specifically, and creating interactable objects. So look forward to it. Anyways, on to the recap.